design of compression members. In this chapter, we are going to study about the various sections that are used for the design of compression members, the types of failures, the load carrying capacity of the member, the members like the angles, the column sections, I sections, the built-up sections, the built-up sections with the laced or a batten system, and let us try to understand what is meant by a compression member. A structural member that is subjected to compressive force is called as a compression member. Now, in the case of a roof truss, the members which are subjected to compressive forces, the internal members which are subjected to compressive force, are called as struts. The vertical columns in the roof truss can be called as stanchion. If you look at this figure, the roof truss, some of the members will be subjected to compressive forces and some of the members will be subjected to tensile forces. Now, in this figure, you can see that this inclined outermost members are called as principal rafter, will be normally subjected to compressive force when this truss is subjected to vertical forces or gravity forces. And this member are called as struts based on the slenderness ratio of the member. Here you find the column sections which are subjected to compressive force. These column members are made of the odd rolled sections. And this odd rolled sections are called as stanchions. These stanchions can be either a single I section member or two I sections joined together by lacing system or batten system, or channel sections placed face to face or back to back. Now, let me show you the 3D models or the various forms of the structural members which are subjected to compressive force. Now, let us look into the 3D model of a simple roof truss. Now, here you find a roof truss let me close down the AC sheet, the roof covering, and have a look on the various components of a roof truss. Now, what we observe here, the topmost cards of the roof truss normally subjected to compressive force due to the vertical loads that acts at the nodal points, and some of the internal members subjected to compressive forces. The other members, what you find here, will be subjected to tensile forces and called as tie members. Here you find that the vertical members at the ends of the roof truss subjected to compressive forces called as stanchions. Now, let us have a look on this members like the struts, normally named based on the slenderness ratio of the member. This top card members, as I said earlier, are called as compression members if it is subjected to vertical loads or gravity loads. Now this internal members, which are called as struts, will be either a single member connected to the plates called as gusset plates. These members can be either a single member or double member based on the force acting in the member. These angle sections can be either an equal angle section or an unequal angle section. In the case of double angle sections, either this connecting member may be a smaller one or a bigger one. So we can connect a long legs back to back on either side of the gusset plate. You can find it like this. There is a single member which is connected to the side of a gusset plate. This leg is called as a connecting leg. The one which is left out freely is called as outstanding leg. So in this case you are finding a single member connected together on one side of the gusset plate. Now if I look at these two members, which are called as principal rafter or common rafter, will be placed on either side of the gusset plate. Now these are the two members which are placed on either side of the gusset plate, either joined together by fastened together by welding connection or bolted connection. So you can find this on either side. So as I said earlier, these members can be of equal section or it can be of unequal sections. Now these two legs are called as connecting leg. These two angles which are projected out are called as outstanding leg. So this connecting legs can be of smaller size or of longer length, and it can be analyzed by placing the different lengths of the legs, and the load carrying capacity could be found out. Based on that load carrying capacity, you can place this either with shorter legs or longer legs. Normally this will be of a longer length. Now let me take the front view of the 3D model. This is a 3D model. So as said earlier, these are the principal rafters, which is normally compression member subjected to the vertical loads. These are the struts. The suspender will be subjected to tension. Therefore, this can be called as a tie member. These two members will be subjected to tension. Therefore, this is also called as tie member. The bottom card is also a tie member. We'll speak about all these tie members when I take up the chapter on design of tension member. Now, just now you observed the angle sections here with single angle section or double angle section subjected to compressive force. Now, let me show you a sectional view of a single member connected together with the gusset plate. Now, this is a part of the compression member, a single angle section connected to the gusset plate. Now, here you can find the bolts, the different grades of bolts that are used in the connections. I'll just rotate this and show you how it is being connected by the nuts and the washers. These are the washers, these are the nuts, these are the bolt. Now, this is a single angle section that is connected to the gusset plate. Earlier in the roof truss problem, you observed the welded connection. Now, here you can go with a double angle section connected on either side of the gusset plate by bolted bolts. These are the bolts placed at regular intervals called as pitch, maintaining the minimum edge distance. You can have a look like this, right? And sometimes you can have the section joined together on the same side of the gusset plate like this. This is two angles joined together on same side of the gusset plate. Now, let us come back to the roof truss model once again. So, this is the roof truss which is supported on the end supports called as columns or stanchion. So, in this model you can see a single I section provided, designed and provided as per IS code. Here you find with a single I section if the load to be carried is of higher order, we can use the single I section with cover plates on either side of the flanges, as you see it here. In this model, if the load to be carried is much more than a single I section could carry, we can provide the cover plates like this on either side of the flanges of the I section as you observe it here, connected together by the bolts or the welding that could be done at the ends of the flange sections here. We'll show it that in the other model. Now this is a built-up column with core plates on either side of the flagship. This is the top view of the section. Now we are interested only in the compression members. Let us have a view on the compression members. Let us temporarily forget about all other components that what you see it here. We'll take up this in the chapter on design of slab bases. We'll come back to this session once again. We'll have a view of this model once again in design of slabs. So this is the typical isometric view of the column section. If the load to be carried is much more, then you can have the built-up columns joined together, two or more members joined together by the lacing system. Now we can have a look here. This is a 3D model of two I sections joined together by a double lacing system like this, where the flats, normally designated as ISF, Indian Standard Flats, which are mirrored together on either side of the flange section. This is what we say. This is the correct way of representing it. The same type of lacing system could be observed on the other face. So that's why we call it as a mirror image. So there should not be any zigzag crossing. The bottommost plate that is provided, the bottommost plate is provided nominally, at the base, is called as tie plate. The same type of sections could also be given just below the roofing. The same type could be provided just below the roofing at the top. If this is the bottommost level of the roof truss, you can also have a tie plate here. This is the 3D model of two high sections joined together. This is the isometric top view. You can observe the typical top view of the connections, which are spaced center to center as per the design and as per the design procedures that are given in IS 800 2007 code. This batten system will also be designed. So let us have a look on the other built-up sections. like channel section, two channel sections joined together once again by a double lacing system with the bolts at the ends. With the bolts at the ends, you're going to have a filler material on one side of the joint connections because it is overlapped with the first lacing plate. And this type of connections, where two channel sections are facing each other, can be called as channels toe-to-toe connection. This is the toe of the channel. It is facing each other. Therefore, we call this as toe-to-toe connection. Once again, you can have the top view. Of the connection, two channels. These are the lacing flats, plates. Now have a look on the front view. This is the front view of the connection. Now let us have a look on this is the isometric view of a two I section joined together by single lacing system connected by end bolts. This is a single lacing system. The angle of inclination as per the code, this is the angle of inclination that is made with respect to the vertical axis of the member. The angle will be measured here. It should be provided according to the code specification. It says that the angle of inclination with the longitudinal axis of the compression member shall not be less than 30 degree and greater than 70 degree. Now have a look on the top view. Let's have a look. Now let us have a look on another 3D model, which is once again a two I section joined together by the single laces system, but this time it is welded together. As you observe it here, these are the weldings that are done at the ends according to the force that is carried in the lacing bar. This is the welding position, and many a times we are going to provide here the welding at the ends, which is called as end return. Normally that will be equal to 2 times the diameter of the weld, 2 times the size of the weld. The length of the return will be 2 times the size of the weld. Now let us go into the channel section once again, where you got a channel section which is placed back to back, and joined together by a double lacing system with bolts either with the bolts or the weldings at the ends. It is left to the discretion of the designer. And observe the top view of this section. Channels placed back to back, laced together by double lacing system. Let us look into any other types that are available. Yes, we have got one more type of connections where a double lacing system or a single lacing could be done by making use of four members, four angle sections like this. You make it into a square column or a rectangular column as per the requirement. So these are the four angles that have been maybe of equal angle section or unequal angle section based on the type of section that is required, either a rectangular one or a square section. So if you observe the top view of this model, it is square in nature. It is square in nature. The angles that are used is of equal length. So therefore this is made out of a equal angle section. Joined together by a double lacing system, as you observe it here. The tie plate at the bottom, and you can also provide the same tie plate just below the roof truss. So in the whole this, what are the members you observed right now? Like the members like I section, the channel section, the angles, channels with face to face or back to back. All this can be joined together by a batten system. So let us have a look on those batten system.